What happens when the sun disappears, but your body still cannot cool down? We are conditioned to believe that the setting of the sun brings a natural reset to the world. In the desert, night has historically been the sanctuary, the time when the earth breathes out, temperatures plummet, and survival becomes manageable again. But in one of the most engineered environments on the planet, that ancient rhythm has been broken. The most dangerous moment of a modern Dubai summer may not arrive when the sun is directly overhead, blinding the skyline and baking the asphalt. It may arrive long after the sun is gone. Imagine stepping outside at midnight. The sky is completely dark, illuminated only by the glowing spires of skyscrapers. Yet, the air is heavy, thick, and profoundly hostile. Sweat instantly beads on your skin, but it does not evaporate. The pavement beneath your feet is actively radiating the heat of the afternoon back into the atmosphere. The hum of tens of thousands of air conditioning compressor units fills the background, dumping even more hot air into the narrow urban canyons. It is past midnight, and the city feels like a sealed room. Dubai was built with unimaginable wealth and technological ambition to defeat the brutal heat of the day, and it succeeded. But the unintended consequence of that victory is something far more complex and insidious. The city is beginning to lose the night. This is not a story about a city that is going to collapse tomorrow. It is not a story about an apocalyptic blackout. It is a story about a highly successful, hyper-modern metropolis that has trapped itself in a cycle of its own making. To protect its citizens, its vital tourism industry, and its global image, Dubai has built a mechanical climate. But why can the danger actually intensify after sunset? And what happens when a city's life support system is never, ever allowed to rest? To understand the invisible trap closing around the city, we have to look past the standard thermometer. We have to look at the biology of human survival. When you step outside into extreme heat, your body has a singular, primary defense mechanism. It sweats. But sweat itself does not cool you down just by existing on your skin. It only cools you down when it evaporates. Evaporation is an endothermic reaction. It pulls heat away from your body and transfers it into the surrounding atmosphere. This is how human beings evolved to survive in hot climates. But this evolutionary defense mechanism has a critical vulnerability. It relies on the surrounding air being dry enough to absorb the moisture. When the air is saturated with humidity, evaporation dramatically slows down. Your body continues to pump out sweat, desperately trying to lower your core temperature, but the sweat simply drips off you. The heat stays trapped inside. Your heart beats faster, pumping more blood to the surface of your skin to radiate heat, forcing your cardiovascular system to work intensely just to keep you at a functional baseline. This is where the concepts of heat index and wet bulb temperature become vital. The traditional 35 degrees Celsius wet bulb threshold is a theoretical upper boundary, a point where a healthy human resting in the shade could not survive prolonged exposure. But we do not need to reach that absolute extreme for things to become deeply problematic. Laboratory studies and real-world medical data suggest that dangerous physiological strain begins at much lower combinations of heat and humidity, especially for anyone exerting physical effort. The symptoms do not look like a sudden cinematic disaster. They look like dizziness. They look like profound exhaustion, nausea, and a quiet loss of thermal regulation. The human body becomes a machine running near its red line, but biology is only half of the story. The human body is struggling because the environment it occupies has fundamentally changed. The city itself is storing the exact same heat that its people are so desperately trying to escape. Dubai is an architectural marvel, a vertical forest of glass, steel, and concrete, erected on the edge of the Arabian Gulf. But from a thermodynamic perspective, this skyline acts as an enormous thermal battery. Every morning, as the sun rises, the millions of square meters of urban infrastructure begin absorbing solar radiation. The highways, the sprawling parking lots, the concrete facades, and the deeply shaded urban canyons soak up the immense energy of the desert sun. This phenomenon is known as the urban heat island effect, but in a hyper-dense, vertical city like Dubai, it takes on a specific and powerful form. During the peak hours of the day, a vast amount of energy is stored within the physical mass of the city. Then, the sun sets. In the open desert, sand has very low thermal mass. It gives up its heat quickly, allowing the night air to chill. But the city is different. At night, parts of Dubai behave like a giant thermos. The concrete and asphalt slowly begin to release all the solar energy they absorbed during the last 12 hours. The heat radiates back into the streets. A comprehensive 2020 study investigating the canopy urban heat island effect in Dubai revealed a striking pattern. During the study period and across the monitored stations, the urban areas were found to be, on average, about 4.6 degrees Celsius hotter than the surrounding rural areas at night. Interestingly, during the day, the rural areas surveyed were often hotter than the dense city center. This beautifully illustrates the trap. The city's geometry provides shade during the day, but it restricts the escape of heat at night. It is a slow, continuous release of thermal energy. The desert may begin releasing the day, but the city is still holding on to it. And this retained heat is waiting right at ground level. What happens when this stored urban heat meets a wave of moist air moving inland from the warm waters of the Gulf? Before we look at the monumental machines keeping the city alive, we must look at who actually bears the physical cost of this changing environment. Dubai's economy, like any global hub, requires constant physical motion, and while a tourist or an executive might only experience the heat in the brief 10-second walk from a cooled lobby to an air-conditioned car, an entire invisible workforce inhabits the actual outdoor climate. Consider a delivery rider waiting for an order outside a restaurant at 8 o'clock in the evening, or a maintenance technician climbing onto a commercial roof to service a malfunctioning cooling unit, or a construction worker returning to a site after the mandated midday break. The United Arab Emirates has implemented crucial occupational heat stress prevention policies. From June 15th to September 15th every year, it is strictly forbidden to assign outdoor work under direct sunlight between 12:30 and 3 o'clock in the afternoon. Employers are legally required to provide shaded areas, cooling equipment, hydration, and first aid. This policy is an essential, life-saving intervention. It acknowledges the lethal potential of the midday sun. But the question hanging over the city is this: what happens before 12:30, after 3 o'clock, and critically, after sunset, when the humidity begins to steadily rise? I used to think a hot night only meant a bit of discomfort, or losing some sleep. But for someone whose livelihood depends on physical labor outdoors, a suffocatingly hot night can mean beginning the next shift before the body has physically recovered from the exhaustion of the last one. It means the physiological debt of the summer continues to compound. The relief never truly arrives. These workers are the ones experiencing the true, unconditioned reality of the environment. Most residents, and certainly the millions of tourists who fuel the economy, can simply escape indoors. But that escape is not a natural right. It is a highly engineered, deeply fragile privilege that depends entirely on an invisible, city-wide machine. Dubai has not merely constructed a lot of buildings with air conditioning, it has engineered a complete, parallel reality. It has built a second climate hidden entirely inside the natural one. You can wake up in a meticulously cooled apartment, walk through a perfectly chilled glass corridor to a climate-controlled metro station, ride in a cold train, and arrive at a sprawling indoor mall where the temperature never fluctuates. The hospitals, the mega resorts, the financial districts, they are all linked nodes in a massive, refrigerated network. The crown jewel of this thermodynamic defiance is perhaps Ski Dubai, a massive indoor ski resort where snow is maintained below freezing, while the air outside bakes at 40 degrees Celsius. It is easy to view this as mere extravagance, but it is actually a profound symbol of the city's core philosophy. Human engineering can override geographic destiny. The engineered climate works flawlessly, and that is precisely why the city has become entirely dependent on it. This dependence is the unspoken vulnerability at the heart of Dubai's massive tourism industry. Tourism is a pillar of the Emirates' economic survival. Millions arrive, expecting a luxury oasis, pristine beaches, and endless entertainment. But when extreme heat and evening humidity make the outdoor experience oppressive, the entire weight of the tourism economy shifts indoors. The hotels, the immense retail centers, the indoor theme parks, they must absorb the full capacity of the city's visitors. If an outdoor cafe becomes unusable, the indoor restaurant must compensate. If a beach walk is too grueling, the mall must provide the alternative. Air conditioning is not merely a luxury in Dubai. In the relentless summer months, it is the city's operating system. It is the fundamental baseline upon which every real estate transaction, every hotel booking, and every retail sale depends. If the illusion of effortless comfort breaks, the economic model is immediately threatened. Visitors do not travel thousands of miles to feel trapped in a hotel lobby, no matter how luxurious it is. The infrastructure must provide an absolutely seamless barrier against the reality outside. But what happens when the natural night no longer provides the ambient cooling that this artificial system was originally built to supplement? To maintain this vast, refrigerated second climate, the city requires immense, continuous power. The physics of air conditioning are ruthlessly simple. You cannot destroy heat, you can only move it. To make the inside of a luxury hotel cold, you must pull the heat out of the air and blast it into the streets. And doing that requires energy. As the days grow hotter and the nights become more stifling, the demand for cooling surges. When the demand for cooling surges, the electrical grid must supply more power. To supply more power, the infrastructure must be constantly expanded and upgraded. Power plants must run harder. District cooling plants, massive industrial facilities that pump chilled water through miles of underground pipes to cool entire neighborhoods, must operate at maximum capacity. This massive energy expenditure generates its own ambient heat, which is expelled into the urban environment, which in turn marginally raises the local temperature, requiring the air conditioning to work just a little bit harder. It is a snake eating its own tail. Now, it is important to state that Dubai is actively racing to diversify its energy grid. The city is pouring billions into the Mohammed bin Rashid Al Maktoum Solar Park and expanding its renewable footprint. According to the Dubai Electricity and Water Authority, clean energy accounted for 16.23% of the electricity produced in 2025. The effort to decarbonize is real, but a solar panel only addresses the source of the power. It does not change the sheer, staggering volume of energy required to sustain a modern metropolis, fighting a war against its own atmosphere. As the afternoon wanes, the massive solar output drops off. The grid must transition. The city braces for the evening, and then the city reaches the hour it has been waiting for all day: sunset. This brings us to the climax of the daily cycle, the moment when the illusion of safety is tested. The sun finally dips below the horizon, the glaring light fades, and darkness covers the vast skyline of the marina and downtown. People begin to step out onto balconies. Outdoor cafes prepare for the evening rush. The number on the thermometer slowly begins to fall. The city looks as though it has survived another day. But a hidden, much more dangerous mechanism is quietly taking over. A fascinating 2024 study, published in Communications Earth and Environment, utilized reanalysis and observational data to examine the southern shores of the Arabian Gulf. It revealed a deeply concerning pattern. The maximum wet bulb temperatures and peak heat index levels in these coastal zones frequently occur in the evening or at night. This phenomenon is primarily driven by the movement of moist, warm marine air sweeping inland from the extremely warm waters of the Gulf. Over the southern waters, this extreme humidity often peaks around 8 o'clock in the evening, and as midnight approaches, this oppressive blanket of moisture can push over the coastal landmass. The thermometer may fall slightly, but the moisture in the air rises aggressively. The capacity for human sweat to evaporate vanishes. Night is supposed to return the body to a baseline state of rest, but when the heat retained by the concrete city violently collides with the heavy, moist maritime air, natural recovery becomes impossible. Comfort becomes another service that must be exclusively manufactured indoors, and the scale of that manufacturing is staggering. Look at the official data from the Dubai Electricity and Water Authority for the year 2025. The city's annual peak electricity demand reached an astonishing 11.39 gigawatts. That is an increase of nearly 6% from the previous year. The total electricity generated surpassed 62 terawatt-hours, and it is not just electricity. Water is the lifeblood of both human survival and large-scale cooling towers. The demand for desalinated water in 2025 reached a record 161.5 billion imperial gallons, with the peak daily demand hitting 487 million gallons. These numbers are almost too large to comprehend, but they are absolutely crucial to the story. That 11.39 gigawatts is not the sound of a city failing, it is the sound of a city succeeding at an extraordinary scale just to keep ordinary life possible. Not all of that power goes to air conditioning. It fuels a booming population, massive data centers, and a growing economy. But cooling is the massive, unavoidable anchor of the summer load. Imagine the reality of that night. The electricity grid is fully operational. The desalinated water is flowing seamlessly through the pipes. The district cooling plants are humming perfectly. The luxury malls are comfortably chilled to 22 degrees. The city is brightly lit and functioning exactly as designed. Nothing failed that night. And that is the trap. Every hotter night demands more cooling. More cooling demands more electricity, more water, and more infrastructure capacity. The economic pressure on the tourism industry, the real estate sector, and municipal services quietly multiplies. The climate does not need to unleash a cinematic disaster to threaten Dubai. It does not need to switch the city off. It only needs to make staying switched on more expensive, more resource-intensive, and more physically demanding every single year. Dubai has not lost power. Dubai has lost the off switch. The engineers and urban planners of Dubai are not sitting idle. They understand the mathematics of this trap better than anyone. The city is engaged in a furious race of adaptation. They are expanding the capacity of power grids and continually investing in massive district cooling networks, which are far more efficient than standalone air conditioners. They are enforcing stricter green building codes, demanding better insulation, smarter glazing, and highly efficient architectural designs. They are pushing forward with the Dubai Clean Energy Strategy to decouple this massive energy demand from carbon emissions. They are even beginning to design rest stations specifically for delivery workers to provide temporary refuge from the crushing evening heat. These solutions are not performative. They are highly advanced, aggressively implemented, and they do work. The system is incredibly resilient, but the tragedy of this infrastructure is the speed of the treadmill it is running on. Can efficiency, clean energy, and new infrastructure continue expanding faster than the rising demands of a growing population and the tightening grip of climate exposure? Dubai is not facing a finite engineering project that can be completed and checked off a list. It is facing an endless, escalating race. The demand is constantly changing. The climate baseline is shifting. The economic imperative to attract tourists and global capital never rests. Therefore, the city can never reach a state of being truly finished. Dubai's engineers are not losing because their machines do not work. They are trapped because every single success creates a larger, more complex, and more energy-hungry system that must be fiercely protected against the environment next summer. When you look deeply into the data, the infrastructure, and the daily reality of the people navigating this environment, a distinct realization emerges. Dubai has not failed, but Dubai is no longer allowed to rest. Return to that image of the midnight street. The air is still heavy. The pavement is still radiating the memory of the afternoon sun. The compressor units are still spinning furiously on the rooftops and in the alleyways. The majestic towers of the marina are glowing against the dark sky. The water is still flowing from the desalination plants on the coast, and the immense electrical grid is quietly bearing the load of millions of lives. Dubai was built as the ultimate proof that humanity could impose its will upon the harshest environments, that we could carve our own bespoke habitat out of the sand. But an entirely artificial environment possesses one fatal flaw. It requires absolute, uninterrupted maintenance. Nature does not need to destroy this city in a single, catastrophic moment to prove a point. It only needs to add one more persistently hot night, one more layer of suffocating marine humidity, one more extended summer season, one more unprecedented peak in energy demand. The towers are still glowing, the rooms are still cold. Dubai has not been defeated by the desert, but behind every illuminated window is a machine that has already begun preparing for the next hot night. This documentary provides an analytical perspective based on publicly available data, historical trends, and official reports available at the time of research. Economic conditions, infrastructure developments, and climate patterns are complex and constantly evolving. This video analyzes systemic pressures and urban planning challenges. It is not intended to disparage any individuals, communities, or the city itself. The content provided is for educational and journalistic purposes and should not be construed as personal travel, financial, or investment advice. If you value documentaries that look beyond the glittering skyline to understand the hidden mechanisms of our world, please subscribe to the channel. The next warning sign is rarely where the brochure tells you to look.